In this video, for our accelerated geometry Mach 2 review, I'm now going over numbers 14 to 23. So continuing with our angle relationships, we're solving for x. I notice here that we have supplementary angles. Now this angle here is 90 degrees, complementary, which means these two angles are technically also complementary, adding up to 90 degrees. So these two values, 3x minus 17 plus x plus 15, are equal to 90 degrees. Now it's just solving for x. So combining like terms, 4x minus 2 is equal to 90. Now you're just solving your two-step. Add 2 to both sides. 4x is equal to 92. So when you divide by 4, that's how you get A, 23. Now 15, draw the picture. We have this angle here of VKW. And KY bisects it. So cutting it into two congruent angles. Now here we go. YKW. YKW. So this angle here is 25 degrees. We are finding the measure of angle VKW. VKW, which is the whole thing. So if this angle is 25, then this piece is 25. So that's why the angle is 50 degrees. Now here, we don't have necessarily an angle bisector. It's just interior. So again, drawing the picture. IGF, and you have GH is inside. Now let's start labeling. IGH, so IGH right here is 2x plus 10. FGH, so FGH here. This angle is 6x minus 6. The measure of IGF, sorry, the little there, IGF, so the entire angle, IGF, this angle is 68 degrees. We're finding the measure of the angle IGH and FGH. We're finding the measure of those two angles. So are these two equal? No, because GH just says it was interior. It's not a bisector, but they do add up to 68 degrees. So that's why the setup is 2x plus 10 plus 6x minus 6 is equal to 68 degrees because the two angles add together to equal 68. Now we're just solving for x and start with combining like terms. So we have 8x plus 4, which is equal to 68. Now we're solving our two-step. So subtracting 4 from both sides. 8x is now equal to 64. So when you divide, you get x is equal to 8. Now, we need to take this x value and plug back in because we're looking for both of the angle measures inside. So angle IGH was 2 times x plus 10. Well, x is 8. So that's why here the angle is 26 degrees. Then angle FGH. Well, FGH was 6 times x minus 6. Well, x was 8. So that's how you get 42 degrees. Now notice, what do the two angles add up to? The 68 degrees. So I know I've got my correct answer here as well. The next set of questions are working with our polynomials. So here we're just needing the parameters. So this side is 8x plus 2. This side is 8x plus 2. So that's why we need to double 8x plus 2. This side here, 15x minus 9. So this side is 15x minus 9, which is why we need to double it. Now, do we need to double the 12x minus 5? No, because the side opposite is inside, and we just need the outside parameter. So just adding to that 12x minus 5. So really what we're combining is 16x plus 4 16x plus 4 plus 30x minus 18 plus 12x minus 5. Now it's all about combining like terms, right? So with all of our x terms, that's how you get 58x. Then here with our constants, that's how you end up with negative 19, which is the parameter. Now 18, we're changing the dimensions. The new width CD is 1 less x unit. So we're subtracting x from our width. And we are adding 3 more units to our new length, BD. So if we were to combine like terms, our width now, our new width is 3x squared minus x minus 4, so that it's in standard form because we have no like terms to combine. However, for the length, we now have 7x plus 5 from 2 plus 3. Now, this is what we're going to use to find the area, which is just multiplying. So setting up our area, 3x squared, negative x, negative 4, and 7x plus 5. Now here, 21x cubed, negative 7x squared from x times x, negative 28x. Then the bottom row, 15x squared, negative 5x, and negative 20. Now combine like terms to find our answer. So we've got 21x cubed. We do have 2x squared terms here, so 8x squared. Here, negative 33x minus 20. And so now with this question, number 19, this is actually also a multiplication problem because we have here that this polynomial represents the number of branches on a tree. So this is the total number of branches. Then this polynomial represents the number of leaves on each branch. And we're looking for the total number of leaves. So if we have the total number of branches and we have the number of leaves on each of those branches, that's why here we have our multiplication. So again, we're going to set up multiplication, and 2y cubed plus 3y squared plus y times 4y squared plus y. Now remember, when multiplying, we add our exponents, right? So this is 8, but y to the 5th, then 12y to the 4th, 4y to the 3rd from y squared times y. Then the bottom, we're multiplying everything by y. So this is now 2y to the 4th. This is 3y cubed, and this is y squared. So now in combining like terms, I have ay to the 5th, so I'll cancel out b and d here. So 8y to the 5th. Then combining like terms, 14y to the 4th. Then here, combining 7y cubed plus y squared. That's why the answer is A. Now, question 20 is division, because as we go through, we are given the formula for density, which is mass divided by volume. You are given the mass. You are given the volume. We're going to do mass divided by volume. Now, notice we're dividing by 7x plus 5. So that is why we need to do long division. So for space, I'm going to go ahead and solve the problem down here. So 7x plus 5. Now, do we need a 0 as a placeholder? 3, 2, 1, nothing. Nope, so no missing term from our exponents. And then again, starting that division process, right? First term into the first term. So 7 divided by 7 is just 1, and 1 less x, so x squared. Now multiply. So these will match up, but don't forget to multiply to the 5 as well. So plus 5x squared. Now here we're going to subtract, change the sign. So this is 0, and now we have 49x squared. Bring down 63x. x. Now divide first term by first term, which gives you 7, or 7x, right? Because we are taking out one x. So now when you multiply, those first terms will match up. But again, don't forget to multiply to 5. 7 times 5 is 35x. Again, we're going to subtract, change the sign. So this is 0, and now we're left with 28x. Bring down 20. Now divide the first term by first term. So 28 divided by 7 is 4. So now when you multiply, you'll match up to get 28x and multiply by 5, which is 20. So now notice when changing the signs, we have no remainder. So here, the density of polynomial expression is x squared plus 7x plus 4. Now 21, we're calculating the height of a parallelogram, which has an area of, sorry about that, has an area of this polynomial here and a base. Now, parallelogram, area is equal to base times height. So again, we're given the area, you're given the base, we're looking for the height. So we're going to work backwards and divide by the base to get the height. So now notice though, this is just x by itself. So we can set up synthetic division. Now again, remember, change the sign in the divisor. So this is -3. Now, do we need a 0 as a placeholder? No, we're not missing any terms. So set up the coefficients. So 2, -1, -20, and 3. Then remember, right, always bring down the first term, which in this case is 2. Now you can start multiplying. -3 times 2, -6. Then combine to and add above. Here you get -7. Now we start the process all over again. -3 times -7, 21. When you combine, you get 1. -3 times 1, -3. You are left with a remainder of 0. So if we started with x cubed, we're now down to x squared. So the height is 2x squared minus 7x plus 1. And now last is identifying our quadrilaterals based on their properties. So going through and labeling A, B, C, D. I'll start with identifying the side length. So for A, B, and slope. So A, B here, I've got, now we're counting by 1. So 1, 2, 3. And here is 1, 2, 3, 4, 5, 6, 7. So to find the length, we've got 3 squared plus 7 squared, then take the square root. So that's how here you end up with radical 58. Now the slope is positive 3/7. So now let's go to our next side, BC. So here, now I've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So 4 squared plus 7 squared. So I can already tell that this is not a rhombus, right? Because not all the sides are congruent. Because now we've got radical 65. Now, and with a slope of, so -4/7. So notice how here the sides are not congruent, but are the opposite sides still parallel to each other? So let's check to see if this is a parallelogram, because we do not have 90-degree angles. So here we've got 3 and 7, yes. So notice how here we do have our opposite sides, and again 4 and 7, opposite sides. So that's why here you have a parallelogram. So now here, again, labeling A, B, C, and D. So let's again start with side A, B. Now notice in this one, we are counting by twos, the lines. So this is going to 4, and then here 2, 4, 6, 8, 10, 12. So now we're going to find the square root of 4 squared plus 12 squared. So now here, that's why we end up with radical 160. Then the slope is positive 4 over 12, which is 1/3. So now let's find BC. So BC is here with our rise and run. So rise is 2, 4, 6, and 2. So here we've got 6 squared plus 2 squared, which is radical 40. Now the slope is negative 6 over 2, which is negative 3. So now notice we might have the different side lengths, right? But we do have negative reciprocal slopes, which means we do have a 90-degree angle. And as we were to keep going, here we have 4 and counting, here we're at 12. So that means again, slope of 1/3, same as the opposite side. Same thing here, 6 and 2. So notice how, because of the 90-degree angle with those opposite sides in the parallel, we have a rectangle.